All right, I see people are still trying to get into the room, so I'm gonna go ahead and get started. For everyone who just walked in, you can tell I try to be a very interactive speaker. I like to get to know my audience. I like to have fun. I hope you have fun as well. Welcome to the From Zero to DevOps Superhero, the Container Edition. Now, before we dive right in, and I know we do have a lot of content to cover, and everyone's super excited to see demos and not so much PowerPoint. I don't blame you. I do want to make sure that I kind of set the stage here and just let you know what you can expect over the next 45 minutes. As much as I say that we're going to go from zero to DevOps superhero, it is physically, scientifically, and probably mentally, and every other elite, impossible for me to just do a brain dump in 45 minutes and impart DevOps and container knowledge. So the title is a little clickbaity. I'm just going to let you know off the bat. However, the goal of the session is not to make you an expert, not to make you the elite, but it's actually designed to get you thinking, to show you what's possible, to get you excited about what's possible and about what you're thinking about, and then offer you resources where you can go and learn more. It's most importantly designed to really set the foundation, maybe redesign the way that you think or the way that you view your CI, your CD, and the way you apply DevOps. So let's go ahead and kind of dive right in. Oh, and one more disclaimer that I didn't have a slide for. If anyone has a ton of questions about GitHub Actions, the extent of my knowledge is I know how to spell the word action. When it was announced, I was actually on a mountain. I was on the top of Half Dome in Yosemite last week, so I had no cell reception. I know just about as much as you do. However, there are links that are in a resource at the end where we actually show you how to run through doing actions with Kubernetes and some CI/CD. So there are resources I'm going to give you. But I know that that's been a hot topic. So now let's go ahead and dive on in. First off, I think we know that life runs on code, right? Life as we know it runs on code. If you compare to 25 years ago or even 10 years ago, the average person maybe had one mobile device or one device that was internet connected. And now, I mean, my sprinkler system is internet connected. You have wireless cameras you just throw up, and you have apps on your phone. Kids have iPads in restaurants. Like, life as we know it runs on code. And for those of us in the room who are developers and operations engineers, we really need to scale with that kind of rapid growth that we're seeing. And just to kind of give a visualization of just how much life runs on code, some of the data on this actually surprises me, but for those of you who download the slide deck at the end, there is a little link to where I got all the data. We have even cars, for example, luxury cars, smart cars, use 120 million lines of code. I actually thought that was interesting because apparently it uses more lines of code than a space shuttle. Space shuttle uses 400,000 lines of code. Your traffic system, so if we take even whatever's in my backpack, computers, phones out, and we just look at life and the commodities that we're used to, everything runs on code. Traffic system uses 5 million lines of code. And we're even seeing advancements specifically in the open source area and specifically as it relates to health. So I actually work with somebody. He's maybe well known, maybe you've heard of him, Scott Hanselman. But he has an artificial pancreas. And he's actually been using, it's open source, the software he uses. He's been using it for 3 years. His life literally runs on code. To run that artificial pancreas is 160,000 lines of code. So that little guy over there in the left-hand corner next to a tree, that's little Scott. You can tweet about him and say, I told you to say hi. But how do we kind of grow with this? How do we scale? And that's really going to lead into why we care about containers and why we care about DevOps. Now, as we've talked about, there's some general things that we know life runs on code, but we even have our experiences. Maybe we have our smart devices that we talked about, our intelligent vehicles. We have retail when you go into a store, and now they just flip the little screen around and you can pay with your Apple Watch or sit there and do PayPass and typing. So we know that there's this definition, right? We have to worry about code. But life also runs on waffles. And you're going to see why. I'm going to try to talk about waffles as much as possible in this particular session. But we want to kind of set the stage for why we care about containers and why we care about learning really this new way to deliver our code. First off, just by a show of hands, how many people in the room feel comfortable identifying themselves as a developer? Awesome. How many people feel comfortable identifying themselves as a sysadmin or operations engineer? Cool, we have a healthy balance. Now, how many people in the room wear whatever hat their boss tells them to wear? Everyone's hands should go up, or we need to have a conversation with your boss. So I'm going to kind of run through this and just tell me if, you don't even have to tell me, but silently tell me if this sounds familiar. And don't worry, this is a slide about developers, ops, I'm going to get to you soon. But for the developers, we often feel as though we need to create applications at a competitive rate, and we don't want IT to be the bottleneck. And then we all know the age-old saying, it runs on my machine, it's your problem. Just give me access to your server, I'll go over there, I'll fix it, there won't be any fires, I promise. You walk over there with a hammer. And then as a result, we tend to feel that my productivity and application innovation becomes suspended because, again, I'm still waiting on IT, right? Essentially, the developer often feels as though IT is the bottleneck to their success, right? They're incentivized to deliver code as fast as possible, especially since life runs on it. But as it turns out, ops is actually incentivized to do the exact opposite. They're incentivized to go against developers because for us, for the operations, and I'm putting on my ops hat now, we need to manage servers and maintain compliance. We need to worry about security of our infrastructure. I can't just give the developer unsolicited access. But if I'm not a developer, I don't know how to integrate this application into my environment. So I really need to figure out how to do this, which means I have to work with you. I don't want to be the bottleneck to a developer's success. But I also can't focus on both server protection and application compliance and security. So that means that I need to worry about the security of my infrastructure and my servers, and I really need the developers to worry about the security of their code. So we really need to work together. But if we're both incentivized to essentially work against each other, one's trying to be agile and deliver code as fast as possible, the other's just trying to keep the lights on, which means as little changes as possible, we have a problem. And that's where we kind of have these stress points. And I always make sure to include the word IT stress points, because a lot of times developers will look at that and be like, oh great, I'm off the hook, it's not my problem. But this is information technology, this is software, this is life runs on code, stress points. If you write code, touch software, touch infrastructure, anything of the sort, this is going to be all of our stress points and therefore a shared responsibility. And if we start working together, we'll no longer be running against each other. So we all want to worry about security, we all want to worry about efficiency, and we all want to support this innovation that we're talking about, this change in our industry. And so just to make sure we set the stage before we deep dive kind of into containers itself, I want to make sure we all are on the same page with the definition of DevOps. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Continuous delivery of value. If you're not delivering value, what are you doing? And why are you doing it? And more importantly, how do you know if you're delivering value? Do you have telemetry, metrics, data, insights, anything into helping you decide whether or not you're delivering value? You can roll code, push updates, run sprints all day long. If your customers don't care about it, or if it's not up, or if you don't have insight into that, you're just throwing money away. And then what's also interesting, and more importantly, is once you have figured out if you're delivering value, how do you keep that value going, right? And so that's the entire purpose of DevOps itself. And that's really why containers become such a hot topic. That's why it becomes so imperative that we kind of adapt. Because for the bottlenecks we talked about with developers, it now enables this write once, run anywhere microservice architecture. For operations, it gives greater portability. It gives standardization across environments. I now don't have it works on my machine. Now I keep it in an encapsulated runtime. I have abstraction. I can take advantage of higher compute density. And most importantly, I can scale as needed. And I can keep all of this in code. I can start aligning with the developers. And what's also awesome is when you take these benefits that containers offers, think about how they apply to DevOps. Remember that prior to DevOps, devs and ops were incentivized to work against each other. Now you focus on this practice and delivering value. Now both people are running towards the same goal together. So now you're creating a unified process. Now, just in case, since this is a superhero talk, I'm going to be making a lot of jokes. Just in case you happen to be part of the movie Endgame and got snapped by Thanos' fingers and have been under a rock for 5 years and don't know what a container is, I just want to make sure we are all on the same page in the room. Remember that a container is not a virtual machine. It's simply process isolation, and it's just a delivery mechanism that's delivering that process isolation. For anybody who comes maybe from the Windows world, it's based on a lot of Linux kernel features. That's why you hear things like namespaces and C groups, what a process can see versus what a process can use. But at the end of the day, a container isn't really a real thing. It's not anything tangible. All it is a delivery mechanism, which is here where your waffle analogy comes in. It's just a waffle. And here's why I say that. How many people like to eat waffles completely plain? No excitement whatsoever. One person, perfect. How many people like all the other toppings? You like whipped cream, strawberries, blueberries, syrup, give me all of it. When you think about it, that waffle becomes the delivery system for all of that extra sugar and all of that extra excitement. At the end of the day, that's all a container is. You're trying to deliver value. You're trying to deliver something that's good, perhaps delicious, but that's all a container is. And it's funny because even though containers have been around for several years now at this point, close to a decade, I still show this slide every time, and cameras always come out, because it's a good visualization of how containers are drastically different from the virtualization that we knew 10, 15 years ago. Before, you had a hypervisor sitting on top of your host OS. Maybe that's Hyper-V, maybe that was ESX from VMware. You still have to manually control your operating system, all your dependencies, and your application. And therefore, each environment is different, right? But over in containers, now you have a Docker engine that sits underneath it, and your container itself is just encapsulated. You have an encapsulated runtime, or maybe you're including your SDKs in your final image, but you have an encapsulated image that's just running your application, ideally with all your dependencies included, and also ideally patched. So remember that containers also have layers, and this is also important because I can't tell you how many customers I go to and how many times I see somebody passing off an SSH key, personal access tone, something, in one of those layers. And they're like, oh, well, it's 5 layers back. It's fine. It's not a big deal, except it's still baked into your image. And now you have a vulnerability. Now you've exposed corporate secrets. So you have to remember how layers work. In your image layers itself, that's your read-only. Your read-write actually happens at the container when you're running it. But now anything else that you've baked in is still accessible. It's still part of that image. So you can kind of think of it like a cake, which I know isn't a waffle, but still has deliciousness. Remember the different layers as you're building. All of these foundational tips are going to help you start towards your superhero container journey. And again, going back to the developers and the operations people in the room, or the jacks of all trades, which is ideally everyone, these are the benefits when we start applying containers. Now we have the ability to iterate more quickly. We have an agile delivery system. We have something that's immutable, so I don't have to worry once I push this up to a repo, now all of a sudden it's going to break somewhere else. As long as the checksum hasn't changed, I have something that is physically unchanged. From IT's perspective, now I have cost savings. I'm not trying to manage several different servers or several different environments. I now can leverage things like orchestration tools like Kubernetes, and I can actually have a series of servers that have a series of different applications, deployments, pods, replica sets, deployment sets, you name it. Therefore, I also can have a more efficient deployment. I know that when it goes to dev, to QA, to staging, to canary, to prod, it's going to be the same. My infrastructure is in code. My application is in code. If I'm using other tools that we'll talk about, I have even the application itself becomes less and less important because the infrastructure around it, the deployment policies around it, doesn't change. It becomes actually part of a chart or part of a package. And as a result, I also have things like elastic bursting, where I can go from a public cloud into a private cloud and vice versa. So as much fun as looking at PowerPoint is, I'm now going to go into a demo. So I'm going to go ahead and end PowerPoint here real quick. And I'm going to switch over to, as soon as I can find my cursor, I'm going to switch over to Visual Studio Code. So I have an application called Spring Boot. This is a Java application, Spring Boot application. It technically has a bunch of Maven dependencies. I've done this before where I've used private Maven artifact repositories. I've done Azure artifacts. I've done JFrog Artifactory. You can use this project with anything. But for the purpose of today, I'm going to try to keep it simple and really focus on tooling that we're going to do for DevOps. If I zoom in on the left-hand side here, you're going to notice I don't have a Docker file whatsoever. I don't have a chart. I'm trying to get started with how do I take this maybe older application and really try to adapt it to DevOps practices and containers and start from scratch. So I'm going to use a tool called Draft. Draft is going to work with Helm. For those of the people in the room who are familiar with containers and maybe use Kubernetes and you've already used Helm, you're aware that Helm is a package manager. You can think of it like NuGet, apt, and pip. Draft works in conjunction with Helm to kind of simplify your creation of those charts or those packages. If you're familiar with another open source tool called Scaffold, it's similar to Scaffold, but significantly easier. So I'm going to do one command. I'm going to do draft create, and I'm going to hit enter. And just like that, it's going to detect my language. It's going to see now I have a charts directory, I have a Docker ignore file, and now I have a Docker file. Now I also want to show you that I'm going to do this first demo completely not even touching a cloud. I actually have Kubernetes running on Docker for desktop. And so if I zoom in here and scroll over, you can see I have a Kubernetes cluster, enable Kubernetes. That's all I'm using. So as a result, from my little developer hat, this is me getting started, not having to worry about anything that my ops or anyone else. I just want to get my code working in a container and in a Kubernetes environment. Now, there are a few things I know I'm going to have to change to this Docker file, and we'll try to zoom in here a little bit. I'll close my command line temporarily. First off, I know my application works on port 8080, so I'm going to go ahead and change port 8080, and I'm going to remove the with dependencies. Now, there's one more line that I'm going to want to make sure that I include, which is going to be to set a user, but I'm not going to do that initially. So I'm going to go ahead and just leave that particular line commented out. And for those of you maybe in the back of the room, this is the line I'm talking about, the user 1000, 1000. That makes it so I'm not running the container as root, but initially I'm going to leave it running as root because there's a reason. Now, theoretically, I could just save this and do Docker run. The application would work inside Docker. But the goal is to get this working in Kubernetes and ideally get this working as part of a pipeline out into the cloud. So I'm going to go over to something called charts, and that's where my Helm package comes in. Helm packages are controlled with something called a values file. You can think of it as your knobs and dials file. How many people love writing YAML from scratch? Okay, one person in the back of the room who's hopefully being sarcastic. If not, we have some masochists in here. So it's crazy, right? Because sometimes it gets very challenging. Tabs are spaces. I just copy and pasted this. Why doesn't this work? Using Helm and using values files simplifies this, and I'm going to show you how. First off, I'm going to control my entire deployment to Kubernetes with this one file. I'm going to make a few changes. The first change I know I'm going to have to make is changing this port to 8080, right? Now, this is also a pretty big application. It uses a lot of dependencies. So I also want to change these CPU requests and limits. So since I don't fat finger anything, I'm going to go ahead and change this first one to 256, replace. I'm going to change the second one, and that's going to be 2512. That's going to be for my CPU and my memory. I'll go ahead and replace, and I'm going to go ahead and save. That looks good. Believe it or not, I'm not running this in a cloud, so I have my port. I already have my Docker file. Let me see if I can go ahead and run this locally. I'm going to do one more command. I'm going to do draft up. That's now going to build my Docker image, and it's going to release it locally. Now, that build is a little misleading because I did run that before, so it built really fast. Normally, it would probably take about 2 to 3 minutes. It has to pull the packages and everything. We'll go take a look at that application after. But in the meantime, I want to start getting this Helm chart ready for cloud deployment. So one of the first things I need to do is define something called an image pull secret. For those of you who are new with Kubernetes, that's where I'm storing my Docker registry credentials to a private registry. I'm storing that in something called a secret. I've previously created a secret called JDK8s, and I've used the kubectl binary to do kubectl, create secret, Docker registry, and then set the appropriate parameters. Don't worry, there's resources to all of these commands, everything I'm running. Everything is on a gist at the end, so you'll have access to this. So the first thing I'm doing is image pull secrets. I'll hit save. The next thing I'm going to do is set something called an ingress. And so I'll go ahead and hit save. And there's my ingress right there, which I'll zoom in here. And an ingress is just old school. For any of the old school Linux sysadmins in here, when you used to have vhost files and comp files, and I'm sitting there messing with my sites and all that, I'm just doing that now in code, And the beauty of it is I actually have annotations with Kubernetes, Nginx. I'm using an Nginx proxy. I'm doing Let's Encrypt. I've pre-configured that on my Kubernetes cluster, and I've done all of that with Helm charts, and I did it in under 15 minutes. So now every single deployment that happens on this cluster is going to be auto-provisioned a TLS certificate, and I don't have to do anything. All I have to do is tell my deployment how to use it. So I go ahead and do that. Now, the one last thing I have to do is I have to add in something called application insights. This is going to give me insights into my application, exceptions, request time, insights into the actual health of the application, not just the pod, not just the container. Again, for the people in the room who are using containers, maybe you're familiar with Grafana and Prometheus, that kind of gives you an overall status of your application. Istio might be a little bit closer to something like this, but this is something I can use inside a container or outside a container. So I'm going to go ahead and make sure that's saved. That looks good. But the problem is anything I specify in a values file has to exist in my template. And this is where it comes down to understanding how these tools actually work and how they simplify and streamline getting started from scratch. You have something that's called a templates folder right here. And in it, you have a deployment YAML, an ingress YAML, a service YAML. For those of you, again, who have played with Kubernetes, who have written these things from scratch, you know how challenging it can be. Using tools like Draft to give you the framework and then Helm to just package everything up really makes it easier. I'm going to go over to deployment, and you're going to notice something here. If I highlight this word values, I have values highlighted throughout the screen. So now I'm using values to essentially reference that values file. Anytime I make a reference to replicas, give me the number of values.replica count. Give me the build ID that's values.build ID. So I'm going to make a few changes. First off, I want my build ID to actually be in quotes because it's numeric, and that's what works with my CI system. Next, I'm going to go ahead and under the container deployment, I need to give it permission to pull that container image, the same one that it says right here on line 21, the values.image repository, values.image tag. I need to give it permission to pull from a private registry. Now, if I am using Azure specifically, whoops, let me go back up here. If I'm using Azure specifically, I could use maybe a service principal or a managed identity. But the average customer is doing multi-cloud. Maybe you're using Amazon, maybe you're using Google. Probably more familiar with using that secret that we created. So I'm going to go ahead and, whoops, let me undo that. I'm going to go ahead and paste in, if values.image pull secret exists, set the image pull secrets to the name that I specified in values. So I'll go ahead and save that. One more thing I need to do is also set an environment variable. So I'm going to go ahead and put in environment variable, application insights, and you'll notice for the values.application insights, if I zoom in, you see values, app insights, instrumentation key. Each period is another indent in YAML. So it makes it a lot easier, number one, to read, and a lot easier to not screw up. And I know that that's a double negative for any of the grammar people in the room. But now my deployment looks pretty good, so we'll go ahead and make sure that's saved. And now I just need to fix my ingress, because the ingress was the last piece on that values file that I changed. For one, if you take a look at the values in ingress, I had a host name. I had annotations. I had TLS enabled to true. But if you go take a look at the ingress, number one, it's expecting values.base domain. So I'd have to change that to values.ingress.hostname. I'd have to enable TLS. I have to put some annotations in. So instead, I have something that I pre-configured where I included if annotations, go ahead and handle the annotations, indent 4 lines or 4 spaces. Do the same thing with TLS. And again, all of these key snippets, by the way, is already in a gist. You literally can save this into AutoHotkey or Keyboard Maestro and reuse it with any one of your charts. I reuse it in every single project I do. It's not specific because it's just code, it's just variables. You're essentially setting parameters. So now I'll zoom out and I'll hit save. And that looks good. That's all I would need for the cloud. Now the last thing I want to do is test my local. Remember, I deployed that. It released out into a local environment. You can see my solar terminal thing there, the color scheme. But let's go ahead and see what's actually happening. I'm going to clear, and I'm going to do k get pods. Now, k is an alias for kube control. But you can see that the application has been running for about 5 minutes over here. And you can see the application is running in a Kubernetes cluster. I could even do k get service. And I can see the same thing, that the service has been running for about 6 minutes. Now, of course, I could do a port forward and connect over it and deal with tunneling and do K logs and all of that, but I can also use draft. So I'm going to use draft, connect, and what that's going to do is actually create a proxy over to the running application, running inside my local Kubernetes cluster. I'm going to run up, I'm going to grab this local host right here, switch over to Chrome, paste a new tab in, and this should be my actual application, which it is. So I'm going to go ahead and go back over here. All of that looks good. I'm going to go over. You can see I've actually already saved all the files that I edited are already actually in Docker or in GitHub. But what I am going to do is I'm going to go ahead and check in this Docker file with that user line commented out. So I'll go ahead and add that in and say live demo. Commit, and we'll go ahead and push. Now, I already have a CI/CD system in place. I took a quick poll of everyone in the room, maybe not everyone, but probably 80% of you in the room prior to starting, and a majority of you are probably already using Jenkins, which probably makes sense as to why we're at Jenkins World. So I already have a Jenkins build server set up, and I'm going to show you that real quick so we can make sure we're all on the same page. Let me refresh this. You can see that build 23 is firing off right now. That's my CI server. If you look at the stages, I'm only doing really up to published container. I'm using this just strictly for CI. So I'm going to go ahead and zoom out. One of the cool things is how I set up this particular build server. How many people love setting up Jenkins completely from scratch? No one? If your Jenkins server crashed today, how freaked out would you be? A lot, right? What happens if I told you I set that Jenkins server up in 5 minutes? I did that using Helm charts. So let me zoom in here. I'm going to scroll over, and I ran a command called Helm upgrade. Helm upgrade with the install switch. Having this install flag right here, all that does is if the deployment doesn't exist, go ahead and install it. Now, I'm also using this file called a Jenkins Values YAML file. Let's take a look at that file, because it's in the same repo that I'm going to give you at the end. If you take a look at this, I'll drop down here, you'll notice the values file starts looking very similar to the file I just showed you from draft. I'm now controlling all the variables. I have my image tag. That's the version of Jenkins I'm installing. I tell it the resource request and limits. Luckily, it doesn't need as much to start, but don't let it exceed more than 2 gigabytes of CPU, 2 gigabytes of memory. Here's the service type I want. I'm using cluster IP, not a load balancer, because I'm going to use Nginx again. Here's my service port. And I'm installing a series of plugins. I'm installing a Kubernetes plugin, a pipeline plugin. I'm installing Blue Ocean, because I like things to be prettier rather than just read logs. TFS, in case I wanted to link that over to Azure DevOps. By the way, I do work for Microsoft, but I'm only using like Azure in this demo, and that's just for Kubernetes. Everything else I'm showing is probably going to end up being third party. And then Aqua Security Scanner. So this is how come I wanted to make sure that I didn't set a new user, a non-root user, because I want to invoke a security policy. I want to show you what happens when I violate a corporate policy. But I need that plugin installed. So I set that up. I installed some script approval methods. I set up my ingress down to the host name that I give it, TLS, if I need RBAC enabled for Jenkins. This is everything running on a Kubernetes cluster, and every single time it actually runs through a build, I'm using Docker in Docker that's taking advantage of that Docker sock that, remember, we saw the Docker engine lives underneath your containers. And as a result, when I go ahead and press this and press enter, this is actually going to deploy locally, and we're not going to watch it finish. But you can notice kget pods -n Jenkins live. It's pending, and it's starting right now in 7 seconds. The same way I deployed the server that I'm using that's running the build in the background is the same way that I just deployed this right now. One line of code, define everything in my Jenkins file, and that's it. I've had my Jenkins server crash when I've been abroad, and I go on stage in an hour, and I'm up and running in 15 minutes, because even my pipeline is in code. And these are really kind of the powerful things to just kind of remember that you want to use when you're starting out with your DevOps journey, when you're dealing with containers. The other cool thing is all of this pipeline is actually a container-based pipeline. Each task is running inside a container. And I give you, I'm going to go into a little bit more detail. I'm doing another session tomorrow. But I give you access to this. This is called Pipeline Groovy. Or not Pipeline Groovy. The name of the file is pipeline.groovy. But if I zoom in here, you'll notice that I define quite a bit of methods. I have a kubectl test method. I have helm lent, Helm package. I'm actually starting that as part of my Jenkins file, and I'm importing that library so that all I have to do in my actual pipeline, if I scroll back over and we take a look at the pipeline itself, is for, number one, you can see all the pod templates and container templates. So each task is running in a container. If I scroll down, we'll find, here's one, pipeline.helmlet, pipeline.helm-deploy. So much so that I've reused this pipeline for multiple projects. All I have to do is change the name of the charts directory, or change the port, or change very tiny key variables, but I'm able to recycle that. And the coolest thing is if you set yours up the same way, you can recycle this as well. You can have yours depend on the same pipeline and take advantage of the same methods. So you can start virtually from scratch. I did not have this pipeline until last night when I just updated it. I copied this from another project, pasted it in, changed the charts directory, checked it in, and that was it. So let's go over and take a look. You can notice that on a failed build, you can see how the image is non-compliant. If I scroll down a little bit, it tells you to create a non-root user. Now, for the sake of time, I'm not going to go through and fix it, but I'm going to show you, once I do add in that user line, this is the result. Now you get images allowed. And all I'm doing is actually using that plugin that I installed from that Jenkins file. So I started completely from scratch. The next thing I did to handle my release and actually get it out is I am using Azure DevOps. And so if I go ahead and refresh this, the release that I'm doing is actually called Jenkins Release. In fact, you can see this deploying right now. You can see here's the latest release, 10:59 a.m. And I can drill down in and see what's happening. Now, again, we talked about starting from scratch, right? Starting with maybe not knowing how to do anything. I built this morning, and it took me less time actually than writing any of the pipeline stuff. And I did that by doing this. I'm going to show you. All I'm going to do is go right here to new release pipeline. I'm going to have to name the stage, which I'll do in a second. The first thing I see is select a template. What kind of application am I deploying? Well, I know that I have a Helm chart that I used with Draft. So I'm going to go ahead and hit that. Now I'm going to go ahead and say dev, close out, zoom out. And just like that, I have my agent tasks. I have install Helm, make sure Helm's on my build server, which is provided for me free from Microsoft, Helm init, and then Helm upgrade. And those same commands are everything that I would run manually. That's that Helm upgrade install command that I ran. In fact, if I go over, I'm going to leave. There's one more task I added in, which was just to add in my private repo. I'm going to go over to releases right here, and we'll go ahead and hit edit. The only other task I added in was I added in this to add in my private repo, and that's where I uploaded my Helm chart from my Jenkins pipeline. From there, if you notice, the Helm upgrade command is deploying out to a namespace. I give it the chart name, which is from my private repo, and then I set the values. This is where I can override those values that were in a values file, so I can overwrite it at release time. The coolest part about this entire demo is when I checked in that code and I go over to commits, I know one of them failed because it triggered that Aqua policy, but I actually have 3 different CI/CD systems working. I had Jenkins set up, I had Azure DevOps set up, and I had a Kubernetes-specific CI/CD system called CodeFresh. And you can see that over here. Here's a demo of one. Now, if we zoom in and look at it, you'll notice throughout the process, starting from scratch, the steps haven't changed. I started out with nothing. I used Draft. I got a Helm chart. I packaged it up. I checked in my code. Those steps stay the same. Then I go ahead and prep my main repository. I build a Docker image. I push it up to a private registry. I package up my chart. And then I handle my promotion. Maybe I do a little bit more creative things, like I send information over to Slack. My Slack notifications are going off here, letting me know whether or not they succeeded. Maybe I'm not using Aqua. Maybe I'm using X-Ray or Anchor. X-Ray, by the way, is a JFrog tool that will also scan your images and your Helm charts. And then maybe I'm finally deploying it with Helm. I have 3 different systems working, and I'm able to test out which one works for me. The best part is CodeFresh also gives you a very similar way where they give you templates and marketplace, where very simply I can just choose to add in these steps. This is what I need for this task. Jenkins, I have that library where you can add in Helm lint, AZ login for Azure CLI if you're using that. Maybe you're using kube control and you want to do a kube control test. All of those are libraries that will make your life easier to get started from scratch. So I'm going to switch back over, and I know there was a lot going on in the demo, so we're going to just kind of recap and make sure that we highlight some of the key points. So the first thing is all the code lives on GitHub, including examples of the Jenkins pipeline that you can reuse. You can copy and paste that, adjust that to your project, and I guarantee you it should work the exact same way as long as you're using Kubernetes and a working Helm chart. Then I use 3 different CI/CD systems because for my enterprise, I want to figure out which one delivers value. I want to have a failover. I want to have redundancy. I want to figure out how I can make sure I'm delivering value. So I used CodeFresh, Jenkins, Azure DevOps, doesn't matter. And that's the key part here that we're going to get to. All the tasks stayed the same, regardless of what system I used. I still built a Docker image, I still packaged a Helm chart, and I still deployed it to Kubernetes. I could have deployed it to Kubernetes on Google or Amazon. Kubernetes is the exact same no matter where it lives. For my Kubernetes repository, I happen to use ACR, Azure Container Registry, and Aqua. But I also had a second server that was CodeFresh that I highlighted over just a little bit. That was using JFrog Artifactory as a private repo and X-Ray. Again, the difference is that the steps, the foundation that all of these tasks run on when you're trying to be a superhero, don't focus on the end goal. Focus on the steps that you're trying to do to deliver value. Those don't change no matter what tools you're using and no matter where you're at in your DevOps journey. This was an example, just to show you that it does work, of a screenshot I took this morning. And that was running it with Java Test Chattybot is CodeFresh, Chattybot, Docker Container CI is Azure DevOps, and then the continuous integration Jenkins. All 3 of them will work. So I'm able to kind of test out new workflows, new processes, and try new things that help me potentially move faster and deliver that life on code faster. Now, I'm just going to make sure we do a brief overview, again, for anyone who was affected by Thanos, that we know what Kubernetes is. It's an open source container orchestrator, originally invented by Google, based on something called Borg. Google's been doing Kubernetes and containers type of orchestration for over a decade now. And it includes a lot of features. In fact, every container orchestrator will include things like self-healing, automatic bin packing, service discovery. It dramatically simplifies your automation, deployment, scaling, and management of your containerized applications. Now, I showed you the draft demo. In fact, that's probably one of the most valuable tools you can have in your resource group as you're dealing with containers. It simplifies Helm. It simplifies YAML. And you can use it with anything that you are using or maybe not using. You just plug it in. It is the de facto, Helm is the de facto Kubernetes package manager. It's powered by a template engine, as you saw. I'm really just plugging in variables and parameters, which if you take a look at that Jenkins file, I'm treating the Jenkins file almost the same way I treat the Helm package. And that Jenkins file, by the way, is also, like I said, open source. But the entire thing is Kubernetes is hard. It's complex. Let's simplify. Now, here's the fun part of the session. I think a lot of times people see from zero to DevOps superhero. Like I told you in the beginning, I cannot make anyone an expert in 45 minutes. But what I can do is try to add a little bit of clarity. I get asked every week, what tool do I use? How do I do this? What system should I put in place? The answer is you can use anything that helps you deliver value. I don't care what solution you use on that board right now. I don't care if you're using Jenkins. If that works, great. If you're already, all I ask is that you still have the foundations, that you use image scanning, that you have a central repository to store your artifacts, maybe your Docker images, your Helm charts. All of that was going up to a central repository, but I'm scanning it to make sure it's secure. Make sure that your code is secure. Maybe you're running white source Bolt or code coverage test to make sure that the code from a developer perspective is secure. I ran my own linting test to make sure my infrastructure was secure. Maybe I'm using GCP or Amazon or Twistlock for container security. At the end of the day, the message is the same. And this is what's going to make every single person in this room a superhero and equivalent to Marvel, which this room already looks like a bunch of Marvel superheroes. It's KISS. And for anyone who's thinking of like bad name calling, no, it's keep it simple, keep it super simple. You don't have to overcomplicate the process. I think a lot of times people get so focused on the buzzwords, containers, Kubernetes, container orchestrator, this sounds great. A lot of times you have to ask yourself, does it deliver value, and is it actually something that is important? Is it going to add unnecessary overhead? In fact, I have a slide that's going to show you that. One of my favorite tweets actually happened a few months ago. Abby Fuller, who works for Amazon, tweeted out saying, "I don't know who needs to hear this, but not everything needs to be a Kubernetes CRD." Again, for the people in the room who are already familiar with Kubernetes, you've heard CRD. For those of you that are not, it is a custom resource definition. So many times people will try to write their own resource definition, their own object, their own method, that they end up taking this simple web app, and now it's like 100,000 lines of code between all your infrastructure, and it's unnecessary. In fact, I often argue that I would ask yourself, does it need to run in Kubernetes? Maybe it can be serverless. Maybe it can be a web app. Maybe it can be something smaller. You don't have to always use the buzzword. But what I loved is Kelsey Hightower, who's considered probably one of the 4 founders of Kubernetes, even repeated it. Hey, Kubernetes community, remember this. Now, because again, you're hearing the superhero theme throughout it, if anybody is an Agents of S.H.I.E.L.D. fan, you're gonna love this. Just remember in life, the steps you take, not only life in DevOps and your DevOps journey, the steps you take don't have to be big. They just have to lead you in the right direction. Agent Gemma Simmons. They don't have to be big. They don't have to do all these grand, elaborate things. They just have to make sure that they're leading you in the right direction to deliver value. And that's going to be the foundation that's really going to make sure you are this container superhero that has good answers. Because it's not just, I know how to do everything with Kubernetes, I know how to build every container in the world. It's, I know how to make sure this works. I know how to make sure we're delivering value to our customers, and I know how to make sure that we're checking that value delivery. One of the things I didn't show you was in my Azure portal, I actually had a dashboard that could show me the insights of that application insights. Now I have the health of my application. And I can pull that data into any kind of dashboard. Maybe it's in a Slack channel, maybe it's in a Microsoft Teams channel, maybe it's in Prometheus. I can parse that into some place where my engineers can access it. Ask yourselves, what are my main objectives? What are my indicators for those objectives? How do I know if I'm actually delivering value and delivering what I promised my customers? I said my SLOs, my service level objectives, or my service level indicators, I told my customers I was going to do this. How do you indicate whether or not you've done that? And then as you're building your pipeline, ask yourself, what will my pipeline look like? What are the tasks I'm going to do manually? You'll notice when I use Jenkins, which I just used a library for, Azure DevOps, which I just used a template for, or CodeFresh, which I just used their marketplace tasks for, I just asked myself, what are the same commands I would do normally? I'm going to go ahead and compile my code. I'm going to build and push my image. Ideally, I'm going to test my code, and I'm going to scan for any vulnerabilities. And then I'm going to deploy to my different environments. Maybe I'll deploy to dev, and then I'm going to test that deployment. Maybe I'll run it through gates. We'll talk a little bit more about that in my session tomorrow. And then I'm going to promote from staging to QA to prod. I'm going to rinse and repeat. And no matter what, those steps, you're just going to be able to choose some sort of tool or option for that. I'm going to use probably a private package feed for compiling, especially if I have any dependencies and artifacts. I'm going to use a private repository. For image scanning, I might use X-Ray, Aqua, Twistlock, Anchor, you name it. By the way, all of those I believe I mentioned have open source options on GitHub. Then I'll use CI/CD. And then I'll go through and I'll do some testing, maybe UI testing with Selenium. I'll do my CI/CD again for that rinse and repeat. The process doesn't change no matter what I use. So I just have to remember the foundation. The foundation is the same. That part doesn't change. This is one of those slides where ask yourself at the end of the day, does it add value or does it add unnecessary complexity? Is it going to add additional overhead or is there actually a return on this? And most importantly, to make sure this is lighthearted, remember at the end of the day, it's just a waffle. We don't have to overcomplicate containers. It's just something that's simple. It's just a delivery mechanism that's ideally delivering happiness to your customers. Some Kubernetes best practices to remember: build small container images. So normally I also sometimes do a deep dive into how I built that pipeline and things that I focused on. But for one, the image that I used was a Debian-based image. I usually like to use Alpine. It's about 25% the cost of it, smaller surface area, smaller footprint, therefore a less surface attack area. Utilize multi-stage Docker builds. You may have noticed that Draft gave me a multi-stage Docker file. Remember your application architecture. So use namespaces, each one of the deployments deployed out into its own namespace so no one would mess with each other. And if something fell over, the other instances are still up. Utilize Helm charts because, again, Helm packages are just going to end up being the same as like a Docker image. It's something you can rinse and repeat. In fact, that Jenkins build server that I installed was from the stable branch. It's from hub.kubeapps.com. It's a public Helm repo, the same equivalent as hub.docker.com. RBAC, which is role-based access control. Don't just give godlike permissions to everyone. Implement health checks. That's something that we didn't go too deep into, but it's where you can set liveness and readiness probes so you know when your container is ready and healthy. If it's not, Kubernetes as the scheduler will restart it. Set resource requests and limits. You did see me play with that on both demos, both from Jenkins and from the Spring Boot application. And then finally, be mindful of your services. Not everything needs to have an IP address. Having multiple load balancers gets expensive, both from a cost perspective and management perspective. So utilize external services where you can. Take advantage of things like Nginx proxies. If you do have a database and you want to rely on geo-replication, data replication, that's where you rely on database as a service maybe. So don't rely on load balancers and map external services. Finally, since I very, very briefly introduced myself, in case you want a picture of me, my name is Jessica Dean. I come to these conferences because I love community and hanging out with engineers like you. And then the last thing, keep your phones out because everyone wants this little present from me. And this is all the links to every single thing I showed you, including all the code snippets, videos that will help you create all this stuff for you. I have various versions of this to prove that you can use the same application with whatever tool set. The foundation and framework doesn't change. And finally, I'll leave that up there, but there's one more slide that says thank you. Thank you, everyone.